Bismillahirrahmanirrahim. The thought of the day is Wala Saufa Yuktika Rabbuka Fatarza, and your Lord is going to give you and you will be satisfied. Assalamu alaikum. My name is Dr. Inshrah. I'm a PGR of Community Medicine and Public Health at King Edward Medical University, Lahore. Today, the topic of my presentation is Spearman's correlation, and I'll be presenting it under current supervision of Professor Dr. Saira Aksar. Our learning outline will be introduction, assumptions, advantages and disadvantages, formula, calculation steps, examples, interpretations, recent updates, and then MCQs. Learning objectives. At the end of this presentation, the participants will be able to define the Spearman rank correlation coefficient, its uses, steps for calculating the formula for computing the Spearman's rank correlation coefficient. Introduction to Spearman rank correlation coefficient. The Spearman ranks correlation is designed to measure the relationship between variables measured on an ordinal scale of measurement. Unlike Pearson's correlation, however, it uses ranks as opposed to the actual value. Spearman ranks correlation coefficient or Spearman's rho is named after Charles Spearman. It is represented by the Greek letter rho or as RS, non-metric measure of statistical dependence between two variables. It assesses how well the relationship between two variables can be described using a monotonic function. Now, what is monotonic function? Monotonic function or monotone function is a function in mathematics that preserves the given order. If there is no repeated data values, a perfect Spearman correlation of +1 or -1 occurs when each of the variables is a perfect monotone function of the other. Assumptions. Some assumptions are made while calculating Spearman ranks correlation coefficient. When applying this type of correlation, one needs to assume that the data is in the form of bivariate random variables. The measurement scale is at least ordinal. Xi and Yi is independent of Xj and Yj, where I is not equal to j. Advantages and disadvantages of Spearman ranks correlation. Advantages of Spearman's correlation includes following. It can be used when data is in the ranked form, example given first, second, third, etc. Less sensitive to bias because of the outliers. This can be used to reduce the weight of outliers since large distances get treated as a one rank difference. It does not require assumptions of normality. It detects any monotonic relationship that may be either increasing or decreasing, not just linear ones. When the intervals between data points are problematic, it is advisable to study the rankings rather than the actual value. Now the disadvantages. Spearman's correlation has following disadvantages. Calculations may become tedious. Additionally, ties are important and must be factored into computation. If the relationship is truly linear, Spearman is less powerful than Pearson's correlation. It only tells the strength and direction of association and it gives no information about the magnitude of change. It assumes a monotonic relationship. It won't detect more complex or non-monotonic associations. Moving forward to the formulas and calculations. The rank correlation coefficient. The computation for the rank correlation coefficient is simpler than those for the Pearson's coefficient and involve ranking each set of data. The difference in ranks is found and RS or Spearman ranks correlation coefficient is computed by using these differences. If both sets of data have the same ranks, Spearman ranks correlation coefficient will be +1. If the sets of data are ranked in exactly opposite way, Spearman ranks correlation coefficient, that is RS, will be -1. If there is no relationship between the ranking, Spearman ranks correlation coefficient will be near 0. Now this is the formula. It is represented as RS, that is Spearman ranks correlation coefficient, is equal to 1 minus 6 sum of D square divided by N into N square minus 1. Now what is D and what is N? D is the differences in ranks and N is the number of data pairs. Moving forward, this is the slide that gives some major steps in calculating Spearman ranks correlation coefficient. The first step is to convert the observed values to ranks, accounting for the ties. Then the next step is to find the differences between the ranks, square them, and sum the squared differences. The third step is the setup of hypothesis to carry out the test and to conclude your results based on the findings. We'll have a detail over these steps in the coming slides. Here, if the null hypothesis is rejected, then calculate the Spearman's correlation coefficient to measure the strength of the relationship between the variables. Now, what does null hypothesis say? Null hypothesis says that there is no relationship between two variables. So it is saying that when this null hypothesis is rejected and we say that there is some sort of relationship between two variables or two values, then we calculate Spearman's correlation coefficient to measure the strength of this relationship. Moving forward, hypothesis. In Spearman's correlation coefficient, there are three types of hypothesis. First hypothesis, that is two-tailed. Second hypothesis, that is one-tailed but moved in the lower direction, so we say one-tailed lower. And third hypothesis is one-tailed and upper. What is two-tailed hypothesis? In the cases of two-tailed hypothesis, there is null hypothesis that says that there is no correlation between xs and the ys. Or in other words, there is mutual independence. When there is no correlation, we say that there is mutual independence between the xs and the ys. Alternate hypothesis says that there is a correlation between xs and ys. Or in other words, there is mutual dependence between x's and y's. In cases of one-tailed and lower hypothesis, a null hypothesis says that there is no correlation between x's and y's. Same, there is mutual independence between x's and y's. And the alternate hypothesis says that there is negative correlation. This lower here is represented by this word, this negative. Negative correlation between the x's and the y. Similarly, in cases of one-tailed and upper hypothesis, we have the same null hypothesis that says that there is no correlation between x's and y's, or there is mutual independence. However, in this case, alternate hypothesis says that there is positive correlation because it is upper. This means that something is moving forward. So here, positive correlation between x's and y's. This is a detail of the steps whenever we find and test the Spearman ranked correlation coefficient. The first step is to state the hypothesis. Whatever hypothesis you are going to assume or test, you state that hypothesis. Then you rank each data set. Then you subtract the rankings, x1 minus x2. The next step is to scale the differences. This is the difference. You scale this difference. And then you find the sum of these scares. The next step is to substitute in the formula. We substitute the value of d and n into the formula. And next step is to find the critical value. Then you make the decisions and at last you summarize the results. This is again the formula for Spearman ranked correlation coefficient. Rho or RS, whatever you want to write, you can write, is equal to 1 minus 6 sum of d square divided by n into n square minus 1. As I have already told, this rho is Spearman ranked correlation coefficient. Di or d is the difference between the two ranks of each observation, and n is the number of observations. We are going to find these ranks. I'll tell you how we calculate these ranks and how we find the differences in the next slides by considering these two examples. This is the first example. This is an example of bank branches and deposits. A researcher wishes to see if there is a relationship between the number of branches a bank has and the total number of deposits in billions of dollars any bank receives. A sample of 8 regional banks is selected and the number of branches and the amount of deposits are shown in the table. At alpha is equal to 0.05, is there a significant linear correlation between the number of branches and the amount of deposits? This is the data set. You can see that these are the different branches we have named as A, B, C, D, E, F, G, H. These are the number of branches of these banks. Say in any country, there are 209 branches of Bank A, 63 branches of Bank B, 19 of Bank C, and so on. And these are the deposits in billions of dollars in each branch. Sorry, in each bank. Now we have to find, is there any relationship between this deposit and the number of branches? And we are going to find this by Spearman ranked correlation coefficient. Now what do? We'll move in a stepwise direction, as I have told you these steps in this slide. Now we will apply all these steps here. The first step is to state the hypothesis. We have to state both the null hypothesis and the alternate hypothesis. The null hypothesis will say that rho is equal to 0. This means that there is no correlation between the two variables. And alternate hypothesis will say that rho is not equal to 0 or there is some sort of relationship between the two variables. The next step is to find the critical value. to find the critical value, we have some tables. These are pre-formed tables. What do? You find the value of n and alpha. In this example, as I have already told, that we have this number of branches, 8. There are total 8 branches, and the set value of alpha in our example is 0.05. So what will we do? We'll take this table, and this, you can see that these are the number of observations. We'll go to 8, and then there are different values for alpha. This is value of alpha for 0.10. This is 0.05, and this is 0.02. So what will we do? We'll find this value of alpha 0.05 for the number of observations we have in our example, because we have 8 observations. So we'll say 8, and here we will see this column where alpha is equal to 0.05. So this value is, this critical value is 0.738. These are pre-formed tables. Moving forward, the next step is to find the test value. How will we do this? We'll find the ranks and differences. This is the same data set as I have already told you. These are the branches, banks A, B, C, D, E, F, G, H, and these are the branches. We'll rank these branches, and in the same way, we will rank this deposit. Now, how do we rank these branches or deposits? I'll tell you in the next example. Here, you just consider that each value has been ranked. Say this is ranked 1, this is ranked 2, then this is ranked 3, this 344 is ranked 3, then we have 209 at rank 4, 201 at rank 5, similarly rank 6, 7, and 8. In the same way, this is the deposit. We have ranked each deposit as 1, 2, 3, 4, 5, 6, 7, 8. I'm again telling you that I'll tell you in the next example how do we rank these values. Right now, just consider that all of these branches have been ranked from 1 to 8, and in the same way, these deposits have been ranked 1 to 8. Moving forward to the next step, what do? We find x1 be the rank of the branches and x2 be the rank of the deposits. We find the difference by subtracting the ranking x1 minus x2. Here, this we are saying that these, all of these are x1 and these are x2. We find the difference between these two ranks by subtracting this value from this. You can see that 4 minus 4, 2 minus 1, 8 minus 6, 4 minus 4, 2 minus 1, 8 minus 6, etc. So we'll find differences for all of, we'll find differences for all of these values by subtracting this value from this. The next step is to scale the differences. When we find this difference, the 0, 1, and 2 is the difference, we'll find a scale for these differences. 0 square is equal to 0, 1 square is equal to 1, 2 square is equal to 4, etc. Then we find the sum of these squares. These are the squares. We'll find the sum 0, 1, 4. Similarly, these are the values for the next data set pairs. Then this sum comes equal to 12. This is the same table. These were the different rankings as I have already told you in this example. These are x1, x2. This is the difference. 4 minus 4 is equal to 0. 2 minus 1 equals 1. 8 minus 6 equals 2. 5 minus 5 equals 0, and so on. Then we'll find the square of these values. 0 square 0, 1 square 1, 2 square 4, 0 square 0, and so on. Then we'll find the sum of all these squares. Sum of these square, these the difference. So sum of these square is equal to 12. 1 plus 4 plus 1 plus 1 plus 4 plus 1 equals 12. Moving forward to the next step, we substitute the values in the formula. This was our formula. Spearman ranks correlation coefficient equals 1 minus sum of 6 sum of d square divided by n into n square minus 1, where n is equal to number of pairs. 1 minus 6 into this sum of d square was 12, as we have already calculated here. Sum of d square 12 divided by total number of observations were 6 into 6 square minus 1. So after calculating these values, we get the final value of 0.657. Now the next step is to make the decision. The decision in this case would be to not reject the null hypothesis, since Spearman rank correlation coefficient has come out to be 0.657, which is less than the critical value of 0.738. This is the value that we have calculated. This is the critical value that we found from the table here. In this table, we found the critical value for our number of observations and alpha. So because this value was 0.738 and our result came out to be 0.657, that is lower than this critical value, so we will not reject the null hypothesis that said that there is no relationship between the two variables, and now we are not rejecting this null hypothesis. In other words, we are saying that we are accepting this null hypothesis that there is no relationship between the number of branches and the number of amount of deposits. The next step is to summarize the result. That is, there is not enough evidence to say that there is a linear relationship between the number of branches a bank has and the deposits of the bank. Moving forward to the next example, the Spearman ranks correlation coefficient is used to discover the strength of a link between two sets of data. Here is another example that looks at the strength of the link between the price of a convenience item, that is a 50 cl bottle of water, and distance from the contemporary art museum. This is the data in the form of a scatter diagram. You can see that here we have the distance of the shops from the art museum, and here we have the price of the water bottle. You can see that one shop is selling it at €2, the next is selling it at about 1.8, then we have 1.2 roundabout, and then we have these three values at 1, then at 0.8, then 0.6, and so on. What will we do? We'll create a table from this data. This scatter diagram will be converted into a table. Then we'll rank the two data sets. That what will be the data sets? One will be the distance of the shops from the art museum, and the next will be the price of the water bottles. Ranking is achieved by giving the rank 1 to the biggest number. As I have already told you in the last example that I'll tell you how do you rank data. So this is the answer, that ranking is achieved by giving the ranking number 1 to the biggest number in the column, 2 to the second biggest value, and so on. The smallest value in the column will get the lowest ranking. This should be done for both sets of measurements. Tide scores are given the mean or average rank. For example, the three tide scores of €1 in the example below are ranked 5th in the order of price, but occupy three positions 5th, 6th, and 7th in a ranking hierarchy of 10. I'll show you what this point is saying. Here you can see that there were three shops that were selling this water bottle at 1. Here, this one, and this one. All of these three shops are selling it at the price of €1. So it is saying that these, because there are three shops and they will get the position of 5th, 6th, and 7th, but you cannot rank these three values at 5th, 6th, and 7th, because we are ranking according to the you can say that size, because the biggest number will get 1, the second biggest will get 2, third biggest will get 3, and so on. So when all of these three shops are selling this bottle at 1, you cannot rank these at 1, 2, and 3. So it says that you give an average rank to all of these three values. No doubt that these will take three positions, but the ranking will be the average of these three positions. How do you calculate this rank? Because they were the three positions of these three shops were 5th, 6th, and 7th. So what do? You add 5 plus 6 plus 7, and then you divide by the total number of these shops. 5 plus 6 plus 7 equals 18. 18 divided by 3 is equal to 6. So when we are ranking, not positioning, ranking, when we are ranking these three shops that give us the value that are selling these water bottles at $1, you will position, no doubt that you will position these three shops at 5, 6, and 7, but you will give each of these shops a rank of 6. That is the average rank. Then the next step is the same. Find the difference of the ranks, sum of the differences between the ranks of the two values on each row of the table. The rank of the second value price is subtracted from the rank of the first value, as we have done in the last example too. Then you scale this difference to remove the negative values, and then you sum this scale, this difference. This is the data set in the form of a table. This scatter diagram here is now converted into this table. You can see that this is just a numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This was the distance of all these shops. Now we will rank this distance, because this 980 meters is the largest distance. So this will get the ranking of 1. 890 is the second value, smaller than 980. It will get rank 2. 790 will get rank 3. 710 will get ranking of 4. 580 will get 5, 6, 7, 8, 9, and 10. This is the price of the bottle. Because the highest price was 2, so it will get the ranking of 1. The second highest price was 1.8. This will get the ranking of 2. Third highest price is 1.2, and two shops are selling it at 1.2. Now, because these positions are 3 and 4, you cannot write this as 3 and this as 4, or this as 3 or this as 4. What do? You sum 3 and 4 equals 7, and because there are two shops that are selling this bottle at 1.20, so you will divide 7 by 2. 7 divided by 2 equals 3.5. So both of these shops will get the ranking of 3.5 rather than one getting 3 and one getting 4. In the same way, the next shops that will be at position, minded position number 5, 6, and 7 were this 1, 2, and then 3. Three shops are selling it at the price of 1. So you cannot write this as 5, this as 6, or this as 7. Rather, what do? You add 5, 6, and 7. You get the collective answer of 18, and then you divide this 18 by 3 to get the final value of 6. So these three shops that were selling it at 1 will get the ranking of 6, 6, 6, and 6. The next value, because that will come at the position number 8, this 0.85 will get the ranking number 8, then ranking number 9, and ranking number 10. You find the difference by subtracting this value from this. 8 minus 2, 8, 9 minus 3.5 equal 5.5, 8 minus 1 equals 7, and so on. Then you find the square of this difference. 8 square 64, 5.5 square 30.25, 7 square 49, and so on. Now you add all of these values to get the final value of 285.5. Now to put all of these values into the formula, find the value of d square value by adding up all the values of difference square column, as we have already done. This value comes out to be 285.5. We multiply this value by 6, because you remember in this formula we had 1 minus 6 into sum of d square. So this 6 represents that coefficient. This 6 multiplied by 28.5 will get the final answer of 1713. For the bottom line of equations, the value of n is the number of sites at which you took the measurements, because this number of observations were 10. So n cube minus n, we get the total value of n cube minus 10 cube is equal to 1000 minus 10, 990. So we substitute these values into the formula. 1 minus, because 6 sum of d square, we have the final value of this 1713. So 1713 divided by the, in the denominator we had n into n square minus 1, or n cube minus n. This value is 990. So substituting 990 here, we do the calculations, and the final result comes out to be minus 0.73. What does this R value means? The closer R is to positive 1 or negative 1, the stronger the likely correlation. Perfect positive correlation is positive 1. Perfect negative correlation is minus 1. You see here, 0 means if this final value of Spearman rank correlation coefficient comes out to be 0, this says that there is no correlation. As we move in this direction towards positive 1, there is perfect positive correlation. If we move in this direction towards negative 1, there is perfect negative correlation. This is a diagrammatic representation. This is for the positive one, where there is total agreement, and you can see that this graph is moving in sort of upper direction. So we say that there is positive correlation. And here in this figure, in this graph, you can see that this is moving in sort of lower direction. So we say that there is total disagreement or negative correlation. Here we had RS value close to 0, RS value close to positive 1, and RS value close to negative. This table says that a correlation coefficient is a numerical measure or index of the amount of association between two sets of scores. It ranges in size from a maximum of positive 1, you can see here positive 1, through 0 to a minus 1. The positive sign, this positive sign indicates a positive correlation. This means that the score on one variable increases as the score on the other variable increases. The negative sign indicates a negative correlation. That means that scores on one variable increases, the scores on the other variable decreases. Interpretations. How do we interpret this? The sign of Spearman correlation coefficient indicates the direction of association between x, the independent variables, and y, the dependent variable. If y tends to increase when x increases, the Spearman rank correlation coefficient is positive. If y tends to decrease when x increases, the Spearman correlation coefficient is negative. A Spearman relation of 0 indicates that there is no tendency of y to either increase or decrease when x increases. Alternative name for Spearman rank correlation coefficient is grade correlation, or the rank of an observation is replaced by the grade. When x and y are perfectly monotonically related, the Spearman correlation coefficient becomes 1. A perfect monotone increasing relationship implies that for any two pairs of data values xi, yi, and xj, yj, that xi minus xj and yi minus yj will always have the same sign. Moving forward to the recent updates, a robust Spearman correlation coefficient permutation test. In this work, we show that Spearman correlation coefficient test about null hypothesis, that is rho is equal to 0, found is most statistical software is theoretically incorrect and performs poorly when bivariate normality assumptions are not met or the sample size is small. There is common misconception that the tests about rho is equal to 0 are robust to deviate from bivariate normally. However, we found that certain scenarios violation of the Bivariate normality assumptions have severe effects on the type 1 error control for the common test. To address this issue, we developed a robust permutation test for testing the hypothesis, null hypothesis, that says that rho is equal to 0 based on an appropriately standardized statistic. We will show that the test is asymptomatically valid in general settings. This was demonstrated by a comprehensive set of simulation studies where the proposed test exhibits robust type 1 error control even when the sample size is small. We also demonstrated the application of this test into two real-world examples. The next update is comparison between ecological momentary assessment and self-report of awake bruxism behavior in a group of healthy young adults. The objective of this study was to self-reported frequency of awake bruxism behavior by means of a validated single observation point questionnaire with the frequency reported in real time with an ecologically momentary assessment EMA over 1 week. The materials and methods Spearman rank correlation coefficient was adopted to test the correlation between average score of each OBC question considered, that is teeth contact, mandible bracing, teeth clenching, teeth grinding, and the average frequency of the corresponding EMA item. The results showed a weak to moderate level of correlation. We concluded that while OBC represents a valid and easy to administer screening tool for evaluating bruxism behavior, the EMA approach provides a more detailed real-time report on AB behavior. Moving forward to the MCQs. A student is conducting a study on a relationship between patient satisfaction levels measured on a 5-point scale and their waiting time in the outpatient department. Since the data is not normally distributed, he plans to use Spearman rank correlation. Which property of Spearman's method justifies its use here? A. It is limited to interval and ratio scales only. B. It requires a normal distribution of data. C. It can be used with ordinal data. D. It can only be used with small sample sizes. Or E. It assumes homogeneity of variance.
C.
Yes, the correct answer is Charlie. It uses ordinal data. A health analyst investigates the relationship between age and blood pressure ranking among hypertensive patients. Spearman's rho shows a strong positive correlation. However, he wants to estimate how much blood pressure increases per year of age. Why is Spearman's correlation insufficient for this purpose? A. It does not apply to continuous variables. B. It only works with nominal data. C. It underestimates all relationships. D. It cannot measure the slope or magnitude of change. Or E. It assumes a curvilinear pattern.
A.
The correct answer is delta. It cannot measure the slope or magnitude of change. It just tells us if there is a relation, if there is positive relation or negative correlation, but it does not change the amount of change. It does not tell about the amount of change. The next MCQ is a composite rating is given by executives to each college graduate joining a plastic manufacturing firm. The executive ranking represents the future potential of the college graduates. The graduates then enter are in in-plant training program and are given another composite rating. To determine ranks correlation coefficient, if null is rejected, the formula used is, these are the different option set. You can tell me which of these formula is correct to find the Spearman ranks correlation coefficient among these 5 options.
B.
The correct answer is eta. 1 minus 6 sum of d square divided by n into n square minus 1. This eta is the correct answer. A public health researcher is studying the correlation between students' stress level and their academic ranking in a medical college. She decides to use Spearman ranks correlation coefficient. She begins by stating her hypothesis, ranks both data sets, and subtracts the ranking. What should she do immediately after calculating the differences in ranks? A. Find the critical value. B. Scale the differences in ranks. C. Rank the values given. D. Make the decision. Or E. Summarize the results.
B.
The correct answer is beta. Scale the differences. Whenever you find the differences in rank, you scale these differences. The next MCQ is, after calculating Spearman's correlation coefficient, a public health analyst compares it with the critical value of 0.05 significance level. What should she do immediately after comparing her results with the critical value? A. Rank the data again. B. Scale the rank differences. C. Make the decision. E. Remove tied ranks or D. Remove the tied ranks or E. Convert ranks to zero score.
C.
Charlie.
Yes, it was obvious. The next step would be to make the decision. Charlie is the correct answer. Okay, if the sum of the square of differences of ranks of 6 candidates in 2 criteria is 21, the Spearman ranks correlation coefficient will be A 0.4, B 0.6, C 0.7, D 1.2 or E 1.5. You will have to do the calculation to get the answer of this MCQ. You are given the total number of observations, that are 6, and then the sum of the square of the difference. That means that sum of D square is 21. Now you will have to put these values into the formula and get the answer. Because we are running short of time, I'll tell you the answer and the calculations. The correct answer is alpha. Alpha is the correct answer. How do you do? This was the formula. This is the formula. Rho is equal to 1 minus 6 into sum of D square divided by n into n square minus 1. Because we were given the value of this n, that was 6, and this sum of D square was 21. So putting these values of sum of D square 21 in here and this value of n here, you get the final answer of this calculation to be 0.4. The correct answer is 0.4. The next MCQ is: a researcher ranks 5 students based on the hour of study and test scores. The rank difference D are 0, -1, 2, -1 and 0. What is the Spearman ranks correlation coefficient? Alpha 0.25, beta 0.30, then 0.50, 0.70 and then 1. I'll show you the calculations again because we are running short of time. This is the formula and you are given the values of these differences. The differences were 0, -1, 2, -1 and 0. You will have to find the square of these differences and sum. 0 square, -1 square, 2 square, 1 square and 0 square. After finding these squares and then adding all of these different squares, you get the final value of 6. So when you substitute this 6 here, and the total number of observations were obviously 5 and 5 here for the n. This sum of d square is 6 and this n is 5. Substituting these values into this formula, you get the final answer of 1 minus 0.3 is equal to 0.7. So here our answer will be delta 0.7. The next MCQ is: a student is studying the correlation between rank in physical activity and stress level among 7 participants. She calculates sum of D square is equal to 14. What is the Spearman ranks correlation? Alpha 0.25, beta 0.50, then 0.65, 0.75 and then 1. For calculations, again we have this formula, and then what do we have? We have the sum of D square is equal to 14 and total number of observations were 7 because participants are 7. So substituting these values into the formula, you get the final answer of 1 minus 0.25 is equal to 0.75. So delta would be the answer. I would have definitely given you the time to calculate, but we are already running short of time. We are just 2 minutes left. So I'll just go through the next 2 MCQs. A hospital study finds a Spearman correlation of 0.89 between the number of weekly physiotherapy sessions and improvement in mobility scores among stroke patients. What does this most likely suggest? The Spearman correlation is positive 0.89. This first option is: as physiotherapy session increases, mobility worsens. B option is: more physiotherapy sessions are linked to better mobility outcomes. There is weak non-linear association. Next option is: there is no relationship, and then the data is not ranked properly.
B.
What will be the answer? Sorry?
Beta.
Yes, the correct answer is beta because we have the positive value of Spearman ranks correlation coefficient. So this means that there is positive correlation, and only this option says that more physiotherapy sessions are linked to better mobility outcomes. So B would be the answer. In a workplace study, a Spearman correlation coefficient is minus 0.88 is found between employee stress level and job satisfaction score. What does this value imply? A, there is strong positive correlation. B, there is weak positive correlation. C, strong negative correlation. D, weak negative correlation. And E, there is no relationship.
C. Charlie.
Yes, the correct answer is Charlie because we have minus 0.88 value and this is very near to -1 because minus sign indicates that there is negative correlation. So our answer would be Charlie. This is the answer key to all MCQs. This is the link to YouTube channel where this presentation will be uploaded. And thank you for your attention.
Thank you.
Thank you so much. It was an excellent presentation.
Thank you so much.